Now I'm going to discuss AC generator. AC generator is a device which is used to convert mechanical energy into electrical energy. Working principle. The working of AC generator is based on electromagnetic induction. That is, when a closed conducting loop is linked with a changing magnetic field, then a current is induced in the loop, and the direction of current is given by Fleming's right hand rule, okay, or Lenz's law. This is the schematic diagram of AC generator. It consists of a permanent magnet to produce a uniform magnetic field B, in which there is a coil PQRS whose ends are connected to two rings known as slip rings, because both the rings slip over the carbon brushes B1 and B2. Okay, and there is a load connected across these two brushes. Load is a kind of appliance like hair dryer, fan, tube light, anything which you want to power up through this generator. And there is a handle attached to the coil which is used to rotate the coil. Okay, this rotation of the coil in the magnetic field produces or induces current, okay, in the coil, and that current will power up the load which is connected across the coil. Now consider you are rotating the coil in clockwise direction, okay, using the handle. During rotation, the arm PQ is moving upward, and the arm RS is going downward. Now consider this arm PQ which is moving upward. It means there will be a force acting in upward direction on this arm F. Okay, and this arm PQ is in magnetic field which is running from N to S. Now the current induced in this part, in this arm PQ of the coil, will be given by Fleming's right hand rule. Okay, when the index finger is in the direction of magnetic field, thumb in the direction of force, then the current is given by the direction of middle finger. Okay, so middle finger pointing P to Q. So the current induced in the arm from P to Q. Now come to this arm RS. The arm is going down. It means the force acting on this arm is downwards. Now point your index finger in the direction of magnetic field, thumb in the direction of force, then the middle finger shows the direction of current, induced current in this arm, which is from R to S. So this is the induced current. Okay, now this current follow this path, okay, and across the load the current is running from B to A. Okay, One thing is to be noted that during first half rotation of the coil, the current is running across the load from B to A. Okay, and during next half rotation of the coil, the current across the load running from A to B. Okay, it means the current across the load changes its direction after each half rotation. So this is very important part of AC generator, that is the current across the load changes its direction after every half rotation of the coil. This type of current that changes its direction after regular interval of time is known as alternating current. Okay, this current is known as alternating current, or in short you can say AC. Okay, so AC stands for alternating current. Okay, alternating current is the current that changes its direction after every half rotation of the coil. Okay. Now I am going to discuss some important parts of the AC generator. First one is coil. This coil is made up of insulated copper wires, and a handle is attached to this coil so that you can rotate it. Okay. Second is, first one is coil. Second is B1, B2. B1, B2 are the carbon brushes. Okay. These are the carbon brushes are connected to the ends of the coils. Okay. There are two ends of the coil, and these two ends of the coil are connected to the carbon brushes. Okay. Now third is S1, S2. S1, S2 are the slip rings. Okay. Slip rings are made of conductor. Okay. The slip rings can slide over the carbon brushes. Okay. So there is a temporary connection between them. So S1, S2 are the slip rings. The important function of the slip ring are to change the direction of current across the load after every half rotation. Okay, so slip rings plays an important role in AC generator to produce AC current, because slip rings changes the direction of current every half rotation. Note it down. Slip rings change the direction of current across the load. Okay. After every half rotation of the coil. Okay. In the case of DC motor, there was split rings that changes current in the coil after every half rotation, whereas in AC generator the slip rings changes the direction of across the load after every half rotation of the coil. Okay, so this is the difference between DC motor and AC generator. Okay, note it down.